Thank you. What I'm going to do is to give you an overview of what I think physics requires the biosphere to do. And I'm going to build on Martine's previous lecture, breathe, fruitful, and multiply to make my point. What I think we need to realize is that this is not really an option. If we do not move into space, if we and our downloads and our artificial intelligence siblings do not move into space, then the entire biosphere is doomed. We know this because eventually the sun will destroy the earth. If we are so foolish as to remain on the planet Earth, then we and the entire biosphere will be annihilated when the sun wipes out the earth. Fortunately, I do not expect that to happen. I expect that the human race and as artificial intelligences and as downloads will in fact move out into space and ultimately take over the universe. Now, what I want to do is to come across today as a fierce physicist, as a firm reductionist, that everything can be reduced to the laws of physics, in particular to the laws of physics, which we now know. Now, people, I notice, have been very hesitant to say that we actually know the laws of physics today. Haven't we made the mistake in the past of thinking that Newton was the ultimate answer, only to discover when Einstein came along, Schrödinger and Heisenberg came along, that no, it was general relativity and it was quantum mechanics that was a better approximation to reality. What I'm going to argue, first of all, is that actually Newton is correct. This is a counterintuitive statement to make, but I can justify it mathematically. Now, I'm somewhat hesitant to speak about mathematics to an audience which perhaps is not familiar with quantum mechanics, with classical mechanics, and general relativity. But I think it's really essential that you understand these basics, because otherwise you might think there will be some new laws of physics coming along tomorrow, which will refute our understanding today. Now, the key thing is that general relativity is really Einstein's theory of gravity, which I think is in fact correct, is really Newtonian mechanics made consistent with the idea that the speed of light is the same for all observers. Now, that insight itself, the speed of light is the same from all observers, is an automatic consequence of Maxwell's equations, just mathematics here, combined, and this was seen first by Lorentz and then the next year by Einstein. Now, how did Maxwell get his equations? Maxwell got his equations because he had 5 fundamental laws coming directly from experiment: Faraday's law, Gauss's law, Ampere's law, no magnetic monopoles, conservation of electric charge. So the 5 laws. Maxwell realized they were mutually, mathematically inconsistent. Conservation of electric charge was directly contradicted by Ampere's law. So what Maxwell did was add a term to Ampere's law that made it consistent with the other equations, and furthermore, he could then derive conservation of electric charge. He only had 4 equations from which the other followed. This was now mutually consistent set of equations, but it implied the speed of light was the same for all observers. Now, let's take Newton's law of gravity. It is not realized generally, but it should be, because it was proven by the great mathematician Élie Cartan in the 1920s that actually gravity is curvature for Newton also. Once you combine that insight with Newton's, with the insight of Einstein and Lorentz, that the speed of light is required to be the same of all observers, then the Newton equations automatically become the Einstein equations. So there is nothing new in Einstein that was not already there in Newton, combined with consistency of reality, which we know is coming from Maxwell's equations. So there's nothing new in relativity. Now, for quantum mechanics, this was proven, the statement I'm now going to make was really proven mathematically, independently by the great physicist Lev Landau and David Bohm, that really quantum mechanics is a subset of Newtonian mechanics in its most general form called Hamilton-Jacobi theory. Now, that means that there was no scientific revolution in the 20th century. What we're still doing when we're using quantum mechanics and relativity, which are in fact correct, is Newtonian mechanics. This is a statement of mathematics which is comparing Newtonian mechanics with quantum mechanics and relativity. This is not generally appreciated, but it's been in the literature for many years, and it's time for everyone to understand this. So, in consequence, I think we already have all the known laws of physics. We already have a theory of everything. All right, now, using this theory of everything, I'm going to generally outline what the future must be. Now, I can do this because if you look at these equations, you will see that Einstein got it right. God does not play dice with the universe. That means reality is deterministic. That is, what we will do in broad outline is, well, actually, it is always in detailed outlined what we're going to do in the future. Now, you have to be careful about that to understand it fully, because remember, one of the consequences of quantum mechanics, which is to say, one of the mathematical consequences of classical mechanics in its most powerful form, Hamilton-Jacobi theory, is that there are parallel universes out there. Many worlds, many universes is already built into the laws of physics, was in the laws of physics in the early 19th century. Physicists would just not admit what their own equations were screaming at them. Time for physicists to do that. Now, one of the things is that we will do is move out from this planet. That is required by the laws of physics, because if we do not do that, we can show that we will have a breakdown in the laws of physics in the ultimate future. Now, how does this work? Well, Stephen Hawking showed about 30-odd years ago that if a black hole were to evaporate to completion, it would violate a fundamental law of quantum mechanics called unitarity. Unitarity is absolutely fundamental, and I conclude I've gone through Steve's equations. I am convinced that he is right, and I also know that unitarity is a fundamental law that cannot be violated. Therefore, what do we conclude? Black holes cannot evaporate to conclusion. Namely, we know, however, there are objects out there which we call black holes. More accurately, they should be called astrophysical black holes, because were they to exist in a universe that would expand forever or accelerate forever, then we would know they would evaporate to conclusion. And they would be true black holes because the information therein would never get out. But in reality, that can't happen, because Stephen Hawking showed that were it to happen, were these objects to exist in an ever-expanding universe, ever-accelerating universe, then necessarily they would violate the laws of physics. Laws of physics can't be violated. So I conclude that it is not possible for the universe to expand forever. It must eventually expand to a maximum size and then recontract. Now you can start applying the laws of physics to the recontraction phase. When you do that, you find you will get an inconsistency. Notice my use of the phrase inconsistency, because what I'm doing here is I am looking at the known laws of physics, and I am seeing what the universe must be like in order for these known and firmly tested laws of physics to be mutually consistent. That's what I'm doing. One of the laws of physics is the second law of thermodynamics, that entropy can never decrease. But if you have a collapse into a final singularity, in which you have horizons existing, horizons, for example, which would exist if you had true black holes rather than mere astrophysical black holes, then you would find there would be an inconsistency between the second law of thermodynamics. Um, so I conclude that cannot happen. One of the things I infer from that is that the event horizons have to disappear. Now I ask, how can event horizons disappear? Well, if you look through the mathematics, there is really only one mechanism that is not of probability zero. If it was probability zero, then that itself would contradict the second law of thermodynamics. What is that possibility? Intelligent life manipulating the entire universe, forcing it into a series of patterns that allow this intelligent life to continue to exist. Only this action will make the laws of physics mutually consistent. Only this action will be consistent with the intelligent life in the far future, following what they must do in order to survive. So I conclude intelligent life will in fact be there near the final state, all the way into the final state, and that this is required by the mutual consistency of the laws of physics, which we can count on because we have never left the original physics, which was established by Isaac Newton some 4 centuries ago. We're still using it. We are still using it when we're doing quantum mechanics, when we're doing general relativity. General relativity and quantum mechanics are really constrained Newtonian mechanics. Okay, now the papers demonstrating this mathematically are on the archive, and my first paper on this demonstrating that general relativity is a subclass of Newtonian gravitational theory was I just received a message this morning that had been accepted for publication in a refereed journal. But you don't need to go to the refereed journals. The mathematical argument is already on the archive. Okay, so what I am saying is that not only will we have the option of survival, namely that it is inevitable we will survive. The laws of physics have dictated it, and if the laws of physics are for us, for the biosphere, for the eventual existence of human downloads and the eventual existence of artificial intelligences, who on earth can be against us? So inevitably we will win. Inevitably we will take over the entire universe. Now, as we're approaching into the final singularity, the laws of physics are also dictating that our knowledge, which is to say our computer capacity, is expanding without limit. Eventually, it will become possible to emulate, to make a perfect copy of every previous state of the entire universe. In that case, once you have been emulated, then we will know it will be us, because one of the fundamental principles of physics, which unfortunately is never dwelt on by professional philosophers, I regret that they seem to be ignorant of this fundamental law, is the principle of indistinguishability. Namely, if two systems are in the same quantum state, they are the same system, just perhaps in different spatial or temporal locations. There are enormous numbers of experimental consequences which follow from this basic fundamental law. It has been repeatedly confirmed over more than a century of experiments, so you can definitely trust it. This basically is the principle of identity that I am going to use to say that these beings in the far future, which have been brought back into existence as computer emulations, are in fact identical to ourselves, to people who have lived earlier in creation. So we can use the laws of physics, applying it to human beings as well as to atoms, which we must do because, after all, human beings are just collections of atoms. We can use this fundamental principle of physics the principle of indistinguishability to establish the identity of these beings brought back into the future, brought back into existence in the far future, to the people that have lived today, that have lived in the past. Now, because the laws of physics are requires that the biosphere continue to exist all the way into the final state of the universe, the final singularity, then we can conclude that since the computer capacity must, by the laws of physics, expand without limit as we're going into the final singularity, that means these emulations can also continue to exist forever and also interact with the various versions of themselves. Because what I'm proposing near the final state is that rather than trying to emulate a imperfect copy, it would not be an emulation, mere simulation in that case, like these imperfect copies which we see in front of us, what you want to do is emulate a perfect copy. Then you will know it is the same as the current copies. And you will also know that when you emulate basically all possibilities consistent with the laws of physics, which is what I am proposing is going to be done in the far future, we will actually get the particular one of you and I that are actually here in this auditorium. Now you might wonder, well, why should we emulate all possibilities? Well, actually, the laws of physics are actually telling us that these all possibilities are already there currently. This is called the many worlds interpretation of quantum mechanics, but I claim it is not the one interpretation. It is really the only interpretation consistent with the laws of physics. As I've said, it is already there in Hamilton-Jacobi theory. It was there in the early part of the 19th century when Hamilton and Jacobi derived their ultimate expression of Newtonian mechanics. It's just physicists would not accept it. Had they done so, had they insisted that these equations be always mathematically consistent, I've recently been able to show that they would automatically at that point have derived the Schrödinger equation, which of course is the basic equation of quantum mechanics. So in general, I want to come across with this final idea that the laws of physics, which we already know, require us to expand out from this planet, which is doomed to be destroyed, or more precisely, not doomed to be destroyed, doomed to be, not doomed, let's erase that word too. It will be the privilege of this planet to be taken apart and used by our human downloads and artificial intelligences to be this planet, material making up this planet will be used to expand the entire biosphere far beyond where it could be if it was merely restricted to the surface of this planet. This, our expansion out into the cosmos, ultimately to take over the entire universe, is built into the laws of physics, which are deterministic, so necessarily this will occur. Okay, that's just a summary of what I wanted to get across for you. And if you want more details of this, you can go look at my popular books, The Physics of Immortality, more recently, The Physics of Christianity, or also go to my technical papers, which are in the refereed journals, or in the short run on the archive. So I'm open to any questions. In which an infinity in quantum field theory is, so to speak, swept under the rug, but has been known since Dyson more than 50 years ago. There is still an infinity in quantum gravity, which is not, which is in all quantum field theories, which is not eliminated by renormalizability, by renormalizing certain constants. Now, what I've been able to show is that if you take into account fully the insights of Stephen Hawking and accept that the final singularity has to exist, then you can absorb these infinities into the final singularity so that they never appear in the laboratory, which in standard quantum field theory they would have to, which means that standard quantum field theory is inconsistent. What I'm doing is imposing boundary conditions on standard quantum field theory and standard quantum gravity to make the theories fully mathematically consistent. That's all I'm doing. Once you get that, you've got a full theory of quantum gravity, but also this quantum gravity theory does exactly the same thing to the standard model, make it fully finite inside the laboratory, which means you've got now, with the Feynman theory, combined with these Stephen Hawking boundary conditions that I am insisting on to make the theory mutually consistent, you have um, the standard model now fully mathematically consistent, and quantum gravity now fully mathematically consistent and consistent with the standard model. So what else there is there to explain? You've got a fully quantized theory of everything. You've got all forces and all material um, entities already included in a fully mathematically consistent theory that is in full full agreement with experiment. So I'm claiming we've had a theory of everything ever since Feynman wrote down his theory in 1964. There have been other attempts to quantize gravity. For example, Bryce DeWitt and John Wheeler proposed a Wheeler-DeWitt equation. I have pointed out in a recent paper that actually these are fully consistent with different expression of the Feynman theory once you impose these boundary conditions to make them mutually consistent, make them, excuse me, mathematically consistent. Does that answer your question?